We present an approach to forecast characteristic 3D poses of human actions. Existing work approaches future human motion prediction in a temporal manner, predicting a sequence of poses at a given frame rate, typically up to 1 second in the future. This means predicting the continuous movement of human pose joints frame by frame at discrete time steps. But for longer-term motion, human movement typically contains action-defining poses at the cusps of joint movement not directly tied to any frame rate. Thus, for longer-term human forecasting, we propose to explicitly capture these semantically meaningful key moments which are characteristic for the goal of an action. We call them characteristic 3D poses. For our characteristic pose prediction task, we consider as input a short 3D pose sequence observation that occurs at any point before the next future characteristic pose, which we aim to predict. An action-defining characteristic 3D target pose may occur at different points in time, depending on the action and speed of execution. Our predictions are thus not limited to short-term future behavior, but can extend multiple seconds into the future. We annotate a dataset for characteristic 3D pose prediction based on the GRAB and human 3.6 million datasets. For GRAB, we use a skeleton representation for each tracked human motion sequence and annotate the times when a characteristic pose occurs. We also annotate sequences from human 3.6M using the same annotation protocol. Our model passes the input pose sequence observation through an encoder, attention module, and a 3D decoder to generate per-joint heat maps, as well as per-voxel joint offset vectors. Characteristic poses are multimodal in nature, as they can occur multiple seconds into the future. We encode this per-joint multimodal distribution explicitly in our 3D heat maps. However, since predictions in grid space are tied to the underlying grid resolution, we simultaneously predict per-voxel offsets. To model interdependencies between joints, we sample poses autoregressively from the joint heat maps with any previously predicted joints encoded along with the input sequence to predict the next joints. We obtain our final 3D pose predictions by sampling the per-joint heat maps to obtain diverse skeleton predictions and adding the corresponding offsets to the initial joint locations. This results in a set of diverse and natural skeleton samples. Our approach outperforms state-of-the-art frame-based predictions, generating more articulated poses on GRAB and human 3.6M data. Our set of pose predictions per input is more diverse than the time-based multimodal baselines, while still capturing the target action pose well. Our approach generates diverse, plausible future poses. In cases where the time between the input sequence and the target pose is longer, such as here in sit or greet, our approach produces a more diverse set of action poses, capturing the ambiguity in the future characteristic pose. When the input sequence is close to the target pose, our approach converges to the most probable poses, for example here in drink, reflecting the reduced ambiguity. Thanks for watching.